subject of this video is the calculation of determinant using Gauss elimination method. The main idea of this method is to transform our matrix to another matrix, upper triangular or lower triangular, where the determinant of matrix upper triangular or lower triangular equals the product of his diagonal element, and after we get the determinant of the first matrix A. For the upper triangulation, we follow the following rules. First, we choose the non-nil pivot from the diagonal elements. Here we choose the first element. If this element equals 0, we change the first row with another row, or the first column with another column. We get new matrix B, where the determinant of A equals -1 power P times the determinant of P, where P is the number of permutation between rows and columns. After we get 0 in the row K under the pivot with the following relation. We repeat the process for the new pivot and we get new matrix upper triangular, which we can calculate its determinants, and after we get the determinant of A. For the lower triangulation, first we choose the pivot. Here we choose the last one. If this element equals 0, we change the last row with another row, or the last column with another column, and we get another matrix. After we get 0 in the row K upper the pivot with the following relation. In the last step we get new matrix lower triangular, which we can calculate determinant and deduce the determinant of the first matrix A. Now we give some examples. We have the first example. A is a matrix of third degree. For the upper triangulation, first we choose the pivot element and we get 0 under this element with the following relation. After we choose a new pivot element and we get 0 under this element. We get matrix upper triangular, which the determinant of this matrix equals the determinant of the first matrix. For the lower triangulation, we choose the last element from the diagonal elements as a pivot, and we get 0 upper this element. After we change the pivot element and we get new matrix lower triangular, which is determinant equals the determinant of the first matrix A. For the second example, we give the following matrix of fourth degree. Here the first row we can't choose 0 as pivot element, so we change the first row and the second row. We get a new matrix. We choose the pivot and 0 under the pivot for the upper triangulation, and we repeat the process. We get upper triangular matrix where the determinant equals minus the determinant of A, because we have changed the between rows one permutation. For the lower triangulation, here we can't choose 0 as pivot element, so we change the last row with the third row. We get a new matrix, and we repeat the process to get lower triangular matrix, and we deduce the determinant of the first matrix A.